In this video, we will add showing enemies to our compass. First, we need an image/icon for the enemy. Make it 60 by 60 pixels and hit create. For the enemy marker, I use two circles. The size of the first one is 38 pixels and make sure it's centered. The size of the second circle is 28 pixels and in blending options, I turn on inner glow with those values. Save it as img_enemy and back to Unreal. Open a HUD blueprint and add new function, add compass marker. Add node construct object from class and as class select image. Out of return value, search for set brush and add it in. Split struct pin and as in brush image, select our enemy image. We want it to be part of the compass, so drag in CP compass and add child to canvas. Connect content with return value of construct image and I adjusted the wires with two reroute nodes and let's adjust the default values. Some of the nodes I am about to add might be unnecessary, but it's better to do more than less. So as I would add it manually, out of return value of add child, search for set anchors and all values set to 0.5 so it's centered. Next, add set size and both values are the height of the compass, so 60. Continue with set alignment, 0.5 for both values and set position to 0. We need to access the marker in the future, so add variable markers, set type to image and change it to array. Drag in its reference, out of it search for add and we are adding the return value of construct image. So we could work with it right away. Add return node, drag the constructed image into it, and rename it the image or marker. We need to update its position, so add a new function and name it setMarkerPosition. Add input parameter, name it marker, and set type as image. Add rotation at target and change it to float. The last one you might want is side lock ? Of boolean type. I add it for now, but in the next video I change it to side lock according to the type of marker. First, we check if the marker will be side locked, so add branch, and the condition goes not boolean of side lock. Out of marker, get slot as canvas slot, and out of it add set position. Split struct pin of in position and connect it after true. Drag in img compass image reference and out of it get desired size. Return value x divide by 360. Multiply it with rotation at target and connect it to in position x of set position. So this will set the position of a marker if it is not side locked. Now we need to know that if it is side locked, whether it is in visible range. So out of the false statement, add another branch. Drag in reference to the canvas of our compass CP compass. get it as canvas slot, get size, and divide it by 2. Get the absolute value of multiplication, check if it's less than half the compass size, and connect it to the condition. By this we are checking both left and right from the middle. If it's true, set the position just as if we would lock it to the side. If it's false, add another branch that decides if we should lock it to the left or right. From a multiplication, just add is greater than, compare it with the half compass size value, and connect it to the branch condition. Copy-paste set position for both statements, and don't forget to connect target with slot as canvas slot. If it's true, positive value, set in position X to the value of half the compass size. If it's false, set it to the negative value of the compass. So, it should be connected like this. Now let's finally get it working. Add a new function and name it update compass markers. Add input parameter, name it compass markers, set it to float for now, and change it to array. Every item in the array should be visualized by a marker, so add for each loop. Drag in get of markers, get a copy, connect integer indexes, and check if the marker we got is valid. If it's not valid, it means that we don't have a marker yet, so after is not valid, add compass marker. If it is valid, we can set its position, so add a call to our function set marker position, and add a separate call after we add compass marker as well. Both rotation at target connect with array element. To the second marker connect image, and to the first one the marker we got. If you want, you can check side lock in the first set marker position to see if you like how it works. The second one will be visible just for one frame each time we add a new compass marker. Now we need to check if we didn't have more markers before, for example if we kill enemies, and hide the unused ones. So after completed, add a branch. Get the length of compass markers and check if it's less than the length of our markers and connect it to condition. Now we hide the unused markers, so after the true statement, add for loop. Into the first index connect the length of compass markers, because length is one more larger than last index of shown markers, and into last index goes length of markers minus 1 last index. Let's realize the loop. Get markers and get copy and connect index with second input pin. Out of get, search for set visibility and add it in. Connect it after loop body and set invisibility to hidden. Now what is hidden must be visible when we need it. So copy set visibility and paste it after we get valid marker, because it could be hidden before. Connect execution pins, into target connect the marker we got and set visibility to visible. This function is done, so move the character blueprint and let's make it work. Add a new function and name it update compass markers. This part will be optimized in the future, but for now just make it work. First, we need to get enemies, so add get all actors of class, and if you don't have it in your project yet, let's create the enemy. Open the content browser and move back to the content folder. Right click, create a new blueprint class, and for testing I just select actor. Name it pp_enemy and just add to it cube so we can see it in the level. Now back to the character blueprint and as actor class select pp_enemy. We must store actors we got, out actors, so add a new variable, name it tracked actors, variable type change the actor, and set it as array. Add in set of the tracked actors and connect it with pins of get all actors of class. We need to go through the whole array, so add for each loop of tracked actors. Now we need to get rotation to enemies, so to make the code more clean, add a new function and name it find relative look at rotation at target. Add input parameter target of an actor type, and the function we use is find relative look at rotation, so add it in and split struct pin of start transform. Out of target, we need to get one part of any actor that has location in the world, and that is the root component. Out of the root component, get world location and connect it with target location. The start transform location, connect get world location of capsule component, and the start transform rotation, connect get world rotation of follow camera. The execution pin at return node, and we need to return only rotation of our compass, so split struct pin of return value, and in the return node drag only return value z yaw. This function doesn't change anything, so set it as pure, hit compile, and back to update compass markers function. Drag out array elements and add our new function find relative look at rotation at target. We need to store an array of floats, so add a new local variable, name it compass markers, set it as array, and change its type to float. Drag in its get, and out of it add. Connect it to loop body, and connect into it return value z. When it's completed, we can finally update the compass markers in HUD. Drag in HUD reference, out of it search for update compass markers, and the compass markers connect get of our local variable compass markers. Last thing is calling this function, so move the function update compass, and after we rotate it, call update compass markers function. Hit compile and move the level. Drag in a few enemies and let's test it. It works, but we also want to show the markers of the closest enemy in the front. So let's implement it. Move back the function update compass markers, delete for each loop, and move all unconnected nodes to the right side. Now we will work with for loop, so right click and add it in. Out of tracked actors, get last index, and promote it to a local variable that I just name tracked actors last index. Connect execution pins and last index. Move to the right and let's implement loop body. Get tracked actors and out of it search for find nearest actor. We need to get the origin vector now. Drag in capsule component, out of it get world location, and connect it to origin. From return value add is valid with question mark, connect loop body with exact, and return value also connect with target. Now if the nearest actor is valid, add compass marker, and because the nearest actor was added into a separate array, we can remove it so we can search for the next nearest actor. So, out of tracked actors add remove item node, connect it after add, and connect into it return value of find nearest actor. When it's completed, get compass markers array and reverse it. And finally, connect it with update compass markers. Hit compile and let's check that it works. If you watch closely, you can see that the marker of the nearest enemy is always in the front as we want it. In the next part we will add more types of markers. If this video was helpful to you, give it a like, and if you want to see more videos like this, subscribe. Anyway, good luck with your project, thanks for watching, and see you in the next part or in another video. Bye!